Hi, welcome to another mini lecture on pre-calculus topic today, using trigonometry to find a length in a word problem with one right triangle. So the characteristic item here is a word problem. Is the most interesting part of mathematics are those word problems, because we are facing something outside of mathematics. Somebody's trying to explain to us something out of the natural world or their environment or something else, and then we have to kind of create a dialogue between that external world and the mathematics that we have developed in our mind. And these problems tend to be very interesting and also sometimes challenging. The standard advice is just pay attention to the world around you. Try to come up with some questions about the natural world that you're dealing with. In this case, measuring various kind of objects that you see around you, trees, buildings, and so on. Last time I mentioned that here are a few challenges, and it looks like here we are actually seeing some of these problems. Let me just quickly review what we had so that we refer to these things. We said you have a triangle and some sides here. You remember the sine of an angle was a ratio of opposite to hypotenuse, cosine was a ratio of adjacent to hypotenuse, and tangent was a ratio of opposite to adjacent. Why just these three, not talk about cosecant, secant, and cotangent? Because they are not on a standard calculator. And why bother? These things are going to do the job for us. Why bring something else in? It's already a crowded situation. Why have something else? Okay, here's an example of a problem. A ladder leans against the side of a house. The angle of elevation of the ladder is 74 degrees. So this is when we want to learn about word problems, we have to be familiar with the terminology of the person who's describing the problem to us. So here's one thing: angle of elevation. This is the angle of elevation that we're talking about. Angle above the ground that you're aiming at something is called angle of elevation. When the bottom of the ladder is 7 feet from the side of the house, 7 feet from the side of a house, so that is, this is the bottom of the ladder and this is the side of the house. Now these problems are tending to be very forgiving because they draw the picture for you. And the real thing is to solve these problems without the picture, meaning that by reading the verbal description you should be able to come up with the picture. So from this to this, you want to try to draw the problem before you look at the problem. Before you look at the picture of the problem. So when you're looking at this thing, and Alex, first cover up the picture, try to see if you can come up with the exact same picture yourself. This skill is going to be necessary. First of all, you're going to see a ton of these type of problems in calculus where all you get is the verbal description, and then you have to come up with the picture yourself. And then of course in engineering situation that's kind of a standard. So translating from the verbal description, so here is the real issue: from verbal to the picture. Can you take on my challenge of doing that yourself and not pampering yourself too much with this thing right now? Okay, so you draw the picture and compare, make sure you did the best you can. Each problem is asking for something. How high is the top of the ladder from the ground? So here, what does this mean? How high is the top of the ladder from the ground? Top of the ladder from the ground. So that's what it means. Once we have the picture, we can isolate it and just throw away the house and everything. And now we have something to work with. Like we came to the mathematical side, that here I know this is 74 degrees and this is my side from the ladder to the house, and what we are after is this, if you want to call it X or H or whatever. So last time we learned how to process this kind of problems. We ask ourselves what relationship connects these three. We are talking about the sine, cosine, or tangent. Which one of them is it? So I have the angle, I have the opposite, I have the adjacent. So the thing to do is to write tangent. Tangent of 74 degrees is the ratio of the opposite to adjacent. So X, I multiplied by 7, is 7 tangent of 74. Again, be careful to put your calculator, Alex calculator, in degrees first. You find tangent of 74 multiplied by 7, and then you're all done. This is going to be a 7 tangent of 74. Now, perhaps somebody wants curious to figure out how long is the ladder itself. So if that was the question, what would we do? Well, let's call this guy Y. Now what is so this is Y. What's the relationship between these three? What's the relationship between these three? So I'll have, well, now I have the adjacent of the angle, I have the hypotenuse, and so I can write, what can I write? Cosine of 74 is 7 divided by hypotenuse, is that right? So if they ask us for how long is the ladder, so cosine of 74 is 7 divided by, well, the ladder is Y now. So last time we learned, quick way of processing is to exchange these two, or just multiply and divide if you wish. Y is 7 over cosine of 74. So we did a little bit extra just to get a little bit more out of each of these problems, and essentially squeezing two problems into one. Okay, so what about here? A 12-foot ladder leans against the side of a house. So here every problem has a bunch of clues, and we try to understand them. Typically information that's given is useful. Sometimes there is a red herring in problems too, but I don't think there's a red herring here. So that is 12. The angle of elevation is 72. We saw this issue last time. Angle of elevation, so that's of course the angle of elevation. And then how high is the question. How high is the top of the ladder from the ground? So how high is the top of ladder from the ground? And that is, well, is referring to this one. Let's go ahead and call that well, let's call that Y. What trig relationship connects an angle to its opposite and hypotenuse? Okay, angle, opposite of the angle, hypotenuse. What is it? We have to pause this and be sure of what it is, and then write it. So of course, you paused it, you have your answer, you come back and say, well, it is sine. Sine of an angle is a ratio of its opposite to hypotenuse. So I do multiply by 12, I get 12 sine of 72 degrees. So 12 sine of 72 degrees you find on a calculator, and then you get to the nearest tenth. What if somebody wanted something else like this? X, how far is the ladder from the house? And now I say cosine of 72 is x over 12, and x is 12 cosine of 72, and so on. And so we have all the information you want. Of course, finding this angle is trivial. If it's 72, that one has to be 18, so they add up to 90. Here is, let's go fly a kite. So fly the kite. A kite is flying 78 feet off the ground. 78, and the picture is helping us. So what is 78? 78 feet off the ground means that's how high it is from the ground, and its string is pulled taut, so there's no slack, or it's not sagging or anything. So that is, this is of course the string here, The angle of elevation, again, that comes out, the angle of elevation is 53 degrees. So here's my angle. Find the length of the string. Okay, so I hope that you try to draw the picture before you come to the problem, but well, we do our best. So let's call this one the length of the string. You want to call it S, for example, if you want. S. So what's the connection between these three? I have my angle, I have its opposite, and I'm looking at hypotenuse. What connects these three? So if you said sine, you are the grand prize winner. Sine of this angle is the opposite divided by hypotenuse. Hypotenuse is the length of the string. So again, we can multiply and divide, or quickly, S is 78 over sine of 53. So X is 78 over sine of 53. You want to have some ballpark figure in your mind when you're doing these things, so in case you do type something wrong button on a calculator and such, what kind of number do we expect for S? Of course, this is going to be bigger than 78. So if we do something here and get an answer like 40, 50 and such, we have to suspect that we did something wrong, perhaps on the calculator or somewhere, and this is alerting us to that fact. What else could we be looking for? Perhaps you can look at X. What is it that connects these three? So you say, what now? I have what trig relation connects the angle 73 to X and that? Well, read it out loud. This is what? This is adjacent. What is that? That's opposite. Angle, adjacent, opposite. Who connects the three of them? Is tangent. Tangent of 53 is 78 over X. So X becomes 78 over tangent of 53. An observant student could say, well, if you have S and you have 78, you can apply Pythagorean to find X. Yes, very good. If you observe that, that is very good. And it's going to be in the class of so-called Pythagorean identities we are going to see later on. So you have multiple ways of coming to the answer. Here, of course, this is perhaps shorter and easier to go this way. Okay, this was another short lecture. So again, application of these trig relationship to finding things such as height of a building. Like here we had the height of building, so I was asking you to calculate the height of the grade library buildings. That is how you do. There's still practical questions, engineering questions that are not all that straightforward. As soon as you try to do any of these things in practice, you will all of a sudden notice, oh, it's not all that easy. If you ever do carpentry, you will realize, oh, it's all triangles, yes, but it's not all that simple. So here is another challenge. Let me give you a challenge. Let me see anybody takes this challenge. So again, we have a picture of, here is a mountain, and I want to know how tall that mountain is. Of course, you cannot put a ladder against the mountain, huh? That would be silly. So we want to find out how tall this mountain is. Let's suppose we are in a kind of a ideal environment, that right next to a mountain there is a flat environment, like we are right next to a shoreline or something, as opposed to a mountainous range where there is no bottom to see anyway. So here I am going to leave that to you. Think about it. Hopefully you'll find it. Okay, so until next time, good luck